Martin, this is the unit nodes for series and parallel circuits. In this unit, I want you to be able to tell when resistors are placed in series or when they're placed in parallel. I want you to be able to calculate the voltage drop across each resistor, no matter what combination they're in. I want you to be able to calculate the current in every wire, no matter what kind of circuit it is. And finally, I want you to be able to calculate the power usage of a circuit, so how much power is used by each resistor. Okay, so to get us started, let's take a moment and review. Um, First off, we have Ohm's law, which gives us the way of calculating, resistance, voltage. Sometimes voltage is called potential difference, but it helps us calculate. So let's say we have our DC power supply. We use the symbol for electromotive force, so that's measured in volts. Within the wire, typically going from positive to negative, we have our current, which is measured in amps. And then we have a resistor, which is measured in ohms. And what Ohm's law tells us is that the electromotive force equals the current times the resistance. Sometimes V equals IR can also be used. Again, resistance is measured with a unit called the ohm, named in honor of Gregor Ohm. And remember that what resistors really do is that they convert electrical energy into thermal energy. And the way we measure how much thermal energy is being converted, we use power. So, for example, a 2-watt resistor will convert 2 joules of electrical energy into 2 joules of thermal energy every second. And the way we calculate power is the current times the electromotive force, or the current times the voltage. And combining this equation with Ohm's law, we can get the electrician's wheel here, where we have combinations for everything. So a resistor with a higher power rating, first off, they tend to be larger, physically. They tend to be a bigger resistor. And if every resistor will have a power rating, this resistor right here that I have pictured is called a carbon film resistor. And usually it has a power rating of about 0.25 watts. If you exceed that, if you go above 0.25 watts, the resistor can malfunction, it can melt, it can catch on fire, it'll basically fail. So you always want to be very mindful of what the power rating is of your resistors, because if you exceed that, you can cause some damage to the circuit. Now, again, this resistor I've shown you is a carbon film, and this is the type of resistor that are used most often, and the kind we'll be using in class. And what you'll notice that there are certain color bands on it. So up here, looking at this resistor, we see that we have 3 color bands, and then a 4th one that's separated from the other 3. Each color represents a number. So with this table right here, we can see that a way of looking at these color bands is a way of finding out how much or how many ohms that resistor has. So a black band is assigned the number 0. Brown is assigned the number 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9. Now there's also these gold and silver bands at the very the 4th color band. That's for tolerance. So looking at the example provided here, we see that we have a yellow, blue, orange, and then gold. So yellow means 4, blue, actually I think that might be violet. Violet means 7. Now the 3rd band is a multiplier, and we see that its color is orange. Orange is 3, so that means it's times 10 to the 3rd. So it's 47 times 10 to the 3rd, or 47,000. So this resistor has a value of 47,000 ohms. And finally, the gold band means that it has a tolerance of 5%. So it's like a plus or minus, or an uncertainty. So let's take a look at another example. Let's say we have a resistor that has a blue band, red band, and then a green band. We won't worry about the tolerance. So, what is the value of this resistor? Okay, well, blue means 6, so we got 6. Red means 2, and green means 5. So this is 6/2 times 10 to the 5th, which would equal 6/2 followed by 5 zeros. So that is 6,200,000 ohms. Or we can do a 6.2 mega ohm resistor, because mega is the metric prefix for million. All right, that concludes video 1.